Okay, so for today's video quiz, the question is, a Thompson's gazelle can run at a very high speed, but its acceleration is relatively modest. A reasonable model for the sprint of a gazelle assumes acceleration of 4.2 meters per second for 6.5 seconds, after which the gazelle continues at a steady speed. The first part of the question is asking what the gazelle's top speed is. In order to find this, I'm going to lay out the given, which is the acceleration is 4.2 meters per second during 6.5 seconds. And then the V initial would be 0 meters per second, and we're looking for V final. Based on the given and what we're trying to find, I'm going to use the V final equals V initial plus acceleration times time equation. So we'll put in 0 for the V initial and 4.2 for acceleration and 6.5 for the time. This will give us the V final equaling 27.3 meters per second. The second question asks or says a human would win a very short race with a gazelle. The best time for a 30-meter sprint for a human runner is 3.6 seconds. How much time would the gazelle take for a 30-meter race? Again, we lay out what we have based on the information, what we're trying to find. I'm going to use the delta x equals 1/2 acceleration times time squared. We put in 4.2 for the acceleration and then 6.5 for the time. That would give us a delta x of 88.73 meters. So the gazelle would complete or run a total of 88.73 meters in the first 6.5 seconds, which means that is greater than the 30 meters that we're trying to solve for. So we're going to use this equation again, but we're going to set delta x equal to 30 and then put in 4.2 as the acceleration. We're going to solve for the time. When we solve for the time is going to equal 3.8 seconds, which means that the gazelle completes the race in 3.8 seconds. The final question, a gazelle would win a longer race. The best time for a 200-meter sprint for a human runner is 19.3 seconds. How much time would the gazelle take to run a 200-meter race? Much like previous questions, we're going to lay out what we're given and what we're looking for. Based on what we're given and what we're looking for, I'm going to use the delta x equals 1/2 acceleration times time squared equation. Again, put 4.2 in for the acceleration, 6.5 seconds for the time. That would give us the 88.73 meters, which we saw up here. But that means that the gazelle only completes the 88.7 meters or 73 meters when in its first 6.5 seconds, which means that there's a certain distance still remaining, since the total distance the race is 200 meters. So we're going to have to take 200 meters and subtract 88.73 meters from it to get 111.27 meters. Then we're going to take this and put this into the velocity equals distance over time equation. We're going to have the velocity equal 27.3 meters per second, and then going to put the 111.27 meters in for the distance, and we're going to solve for time. When we solve for time, time is going to equal 4.1 seconds. So it's going to take 4.1 seconds for the gazelle to complete the remainder of the race. Since we have two different times that we're going to have to substitute in or include in our total, we're going to have to add the 6.5 seconds where the gazelle is accelerating, and then the 4.1 second where the gazelle is maintaining a constant pace to complete the remainder of the race. This will give us a total time of 10.6 seconds.